Good afternoon, everyone. I welcome you all to this online event, ASTROMINAR, that is being organized by Astronomy Club of Government College of Engineering, Nagpur.
Anurag Maldhure and I am second year coordinator of the club. So now before we get started, I would like to request principal of our institute, Dr. M.B. Komtekar sir, to address the meeting.
Sir, sir, kindly unmute your mic.
I hope now audible.
Yes,
Hello.
yes sir, you're audible.
Yes, sir,
Yes.
Yeah.
perfect.
Yes,
Good
sir, you are audible,
afternoon.
sir.
Yes. So it is really a pleasure for me to address the interested students in the field of astronomy. Government College of Nagpur has started this astronomy club with the initial efforts of Mr. Rohit Intolkar couple of years back with the great support from the enthusiastic faculty, Dr. Randhawa. In fact, at that time, we have very small, say, support or equipment which is required to go for the grazing. But with the zeal, with the enthusiasm of the Rohit and his team, even though we had lost less resources, this club was very, very active and one of the most active clubs from Government College in Nagpur. Right from the day of inception, they have conducted so many events like the sky gazing or celebrating or giving information about the say solar system, conducting the events with the help of some eminent people like Professor Mahabar from USA. We have good contact with the Raman Science of Raman Science Nagpur, and now every now and then they are conducting the events for the people, for the students. Even we have good connect with the various schools of Nagpur, so that the interest can be created about the astronomy. And today there is one big event which is called a solar eclipse. And now you also observing they are taking the efforts to show you the live solar eclipse by from Ladakh by with the help of Indian Institute of Astronomy. So I really congratulate the team and the leader, Dr. Mr. Randhawa, for taking care of this astronomy club. And today, we Astronomy are one of the major events conducted this year, despite we have the problem of COVID-19. Still, they are celebrating or still they are conducting the event like Astronomer. I congratulate the whole team of Astronomy Club. I congratulate the faculty members. I am sure students and all the faculty members across country will enjoy this particular astronomy hour. Thank you very much, and I wish you very best of luck. Thank you.
Okay, thank you sir for your encouraging words and your valuable support. So I will first give a brief introduction of our club. Yeah, so club was inaugurated on 3rd of Feb. Uh, 2017 on initial lead by Rohit Chinchwadkar and inaugurated by Principal Sir. And since then, the club has been conducting various activities for students of institute as well as for the students of school and colleges in the Nagpur district region. The club functions under the guidance of Principal Dr. M.B. Kumthekar Sir and faculty in charge Dr. J.B. Randhawa Ma'am from Department of Physics. The major activities in the past include the observation session using advanced telescopes of major astronomical events like conjunction of Mars and Jupiter and lunar eclipse. Back then, we had expert talk Dr. Ashish Mahakur, who is senior scientist at Caltech USA, on the topic our own astronomical experiments we can take as engineers and students from other stream in the field of astronomy. Sorry for inconvenience, but I would request everyone to mute their mic. Okay, so continuing with the session. In this picture, you can see the telescope that here we have in our college. It is Celestron LCM 114. It is a 5-inch diameter reflective type computerized Newtonian telescope. This is the first image that we captured from our telescope. It looks more clear than time. The picture is PCB of the cameras. Also, in the it remains and center. And for the school kids of nearby session, here the picture of the telescope that you can see 11-inch diameter telescope of conference on physical events that is CPUCT. Club has been organizing annual events, namely Star Quiz and Stargaze. Among these, Stargaze is a free inter-school quiz competition for high school students in Nagpur. This consists of 10 exciting interest in field of astronomy to test their knowledge. Secondly, the Stargaze is a two-day workshop organized that is the technical phase of our day. It includes basic of astronomical, observational astronomy, telescope handling, software handling, and observation section, and it's a paid event. Then recently even had interaction with Dr. U. Abhirav. He was the program director of the mission, which was the first anti-satellite mission of India, which was a successful technological demonstration. Then we also had the delegates from Vigyan Bharati in that meeting. So we also carry out induction programs for newly admitted students and interested students in our institute. And these club activities are carried out by the core team of the club. So that was all about the club. So now getting to a seminar, we will be discussing the following topics. First one is the significance of astronomy for ancestors by Soumit Nayak and Shantanu Kawale. Second will be the light in astronomy by Ashutosh Acharya. Third is the space exploration by Abhirav Welekar. Fourth is space agencies presented by Shashwat Buradkar. And fifth one is the remote observational session that will be jointly coordinated by Rohit Chinchwadkar, Atharva Pimpalgaonkar, and Shantanu Kawale. So hope you gain the most out of it. And if anyone has any question regarding these topics, you can type the question in the Q&A section in the present in the more options. You can see the three dots below. There, if you will click, you will find the Q&A section. We will try our best to answer all your questions. So sit back and relax. So let us begin with the session. For the first topic, I would ask Shantanu and Soumit to proceed. Thank you. So Shantanu and Soumit, please proceed with your presentation.
Yes,
Yes.
sure. I was just loading up.
Okay, fine.
Yes, it has loaded up. So we
Yes.
shall start now.
Okay.
Yes, you can start.
Thank you, Anurag. And I also express gratitude towards all the participants who have joined today's webinar. Humankind has come a long way in astronomy. We have probes in the interstellar space and pictures of black hole itself. But where did it all begin? It started with curiosity of a few civilizations. The prominent ancient civilization in astronomy will be explained by me and my friend Soumit Nayak. Starting with the Indian civilization, Soumit, take over the mic.
So starting with Indian civilization. So in India, astronomy has been a great deal from a long time. So there are three predominant astronomers which who have made great deals in progress in the field of astronomy. So here are Aryabhatta, they are Aryabhatta, Bhaskara II, and Brahmagupta. So starting with Aryabhatta. So as we all know, Aryabhatta is a great mathematician, but he was a great astronomer too. So unlike the masses which believed the sky rotated and the earth was stationary, he believed the earth to spin on its own axis. So the masses at that time believed that the sky used to rotate around the earth, but Aryabhatta did some calculations and found out that's not the case. In fact, the Earth is actually rotating, and we are rotating along with it, and the sky is stationary, thus it appears to be moving. Next, he explained the solar and lunar eclipses with proper scientific explanation, and also stated that the moon reflected the sun's light rather than giving off its own light. So back then, people used to think that the moon used to give off its own light, but Aryabhatta refuted that and said that moon actually reflects the light from the sun. And he also explained the concepts of solar eclipse and lunar eclipse in scientific term. As you know, today is a solar eclipse, so yeah, that's a huge plus. So next, his calculations on the mean speed of the planets with respect to Earth suggested towards a heliocentric model. So he plotted out some planets in the night sky and used to calculate the movement speed with respect to our Earth. And according to his calculations, it is predicted that the solar system is rather heliocentric rather than what the masses believed to be a geocentric model. So sun is in the center of the solar system, but the masses used to believe that the Earth is in the center of the universe. So coming on to the next great astronomer, Bhaskara II. So Bhaskara II, he accurately defined many astronomical quantities, including the number of days in a year, which is he calculated to be 365.2588 days, which is very close to our modern accepted value of 365.25636 days. So according to his means back in his era, that number is pretty significantly close. Next, he was a great mathematician and calculated the sunrise equation, predicting the sunset and sunrise using only three variables. So he took some variables that are hour angle, declination of the sun, and the latitude of the observer. Using those three variables and some simple geometry, he could calculate the time at which sun used to rise and the time at which sun used to set, which is incredible equation if you ask me. Next, he contributed a great deal to Indian astronomy with advancements in understanding of eclipses, conjunctions of planets, and other celestial bodies. So conjunctions are pretty important. Like the French astronomer Urbain Le Verrier, using the conjunction of Mercury with respect to the Sun, actually calculated how the orbit of Mercury moves, and thus conjunctions are important. But yeah, Urbain Le Verrier did that in 1700s, while Bhaskara II was alive in 1100s, and he knew about conjunctions and the important and the significance back then, which is astonishing. Next astronomer is Brahmagupta. So Brahmagupta, he explained the phases of the moon and refuted the idea of the moon being farther from Earth than the sun. So the masses back then used to believe that the moon is farther from the sun. That's why it is not that bright. But he knew that that's not the case and provided scientific evidence that moon actually reflects the light of the sun and it's in fact nearer to us. And then he worked on longitudinal mapping of planets and wrote about his work in his treatise Khandak Adhyaka. So as you know, longitude on Earth are simple to understand because we live on Earth. But if you watch planets, so but you cannot map them out without a good optical instrument, and he did not have great optical instruments. So even though with his limited resources, he tried his best to longitudinally map the planets. So that brings astronomy, the topic of astronomy in India to an end. Moving on, we have astronomy in Mesopotamia, which will be explained by my friend Shantanu.
Thank you, Soumit. So, astronomy in Mesopotamia. Mesopotamia was a region which was divided and governed by three kingdoms. And the most prominent kingdom in astronomy out of all those three was the Babylonian kingdom. So, the Babylonian astronomy can be divided into two parts: Old Babylonian astronomy and Neo Babylonian astronomy. Coming on to Old Babylonian astronomy. The old era consisted of mathematicians. They divided the night sky into three parts of 30 degrees based on various constellations. So, the old era of Babylonian astronomy consisted of various mathematicians, and in mathematicians, they were pretty proficient. They divided the night sky into three equal parts of 30 degrees just based and observing the different constellations of their mythological beliefs. The Babylonians were the first civilization known to possess a functional theory of the planets. Now, what do I mean by the functional theory of planets is that a theory which consisted all the observed planets and the sun into a system. and the system can be influenced by your mythological or your scientific beliefs. So they possess the functional theory of planets. They were the first civilization to do so, in fact. Astronomers had developed a catalog, which can be seen to the right, which recorded the eclipses and other important astronomical events. And astronomy, everything is not about observing, it is also about observing and noting down the details of the astronomical events. So they do note it down and carried on their knowledge to further generations by developing the star catalogs. So moving on to the Neo Babylonian astronomy. They believed in a heliocentric model of the solar system. Now, believe me when I say that it is a big deal because everyone in the BC millennials, everyone believed in the geocentric model of the solar system, which is that the Earth is at the center of the solar system and the sun revolves around it. But the Babylonian astronomers of the New Age refuted this idea and came up with another model of the solar system, a heliocentric model of the solar system, which till date we use just with elliptical orbits and more accuracy. The New Age astronomers were mostly concerned with the early age and state of the universe, and more focused on the trajectory of various different celestial bodies, and it was independent of astrology. Now, any astronomer of the Neolithic age, like the Babylonian age, the Babylonian era, can fall into the trap of astrology, but the astronomers in the Neo Babylonian age were different. The astronomy of theirs was independent of astrology. They were concerned about the state of universe, how the universe began, what will the universe be, did it was it always here, and various other things, or like the trajectories of various different celestial bodies. They also believed in an elliptical orbits of planet. Now, this brings the astronomy in Mesopotamia to an end. But we have another civilization which will be again explained by my friend Soumit, the Greek civilization. Soumit, please take over.
Thank you, Shantanu. So, astronomy in Greece. So, as you all know, Greece is a powerhouse of a civilization in various fields, like whether it be architecture, as you can see over here, mathematics, and astronomy was no less. They had great astronomers. So, in Greece, astronomy can be divided into two eras: classical Greek astronomy and Hellenistic astronomy. So, coming on to classical Greek astronomy. So, in classical Greek astronomy, the astronomers differentiated celestial bodies which move relatively fast from other celestial bodies, calling them planetes, meaning wanderers, which in today is known as planets. So, they used to observe the night sky on a daily basis and used to look at all the stars, all the shiny objects. So, there used to be stars and planets alike, but how did they differentiate stars from planets? Is they used to observe them daily, and the objects which moved relatively faster, and so they call them planetes, which means wanderers, and that word has become planets now. Now we call them planets. Next, Aristarchus in the 3rd century BC proposed a heliocentric model. Hence, he is also referred as a Greek Copernicus. As my friend Shantanu said, that heliocentrism is a big deal because back then the masses used to believe in geocentrism. But Aristarchus in the 3rd century BC, which is about 2200 years ago, proposed that the sun is in fact in the center of the solar system and the planets revolve around it, which was a great day because Copernicus, who is credited with the heliocentrism model in the modern era, which he discovered in 1700 AD, is he developed that theory much later to Aristarchus. Next, Eratosthenes, a polymath by degree, calculated the circumference of the Earth using simple geometry with an error on the real value between minus 2.4% to positive 0.8%. So back in Eratosthenes era, so what he did was he visited Egypt, and in Egypt he took two cities, and what he did was at the same time he asked his friends at another city to measure the length of the shadow of the well, and while he used to measure the length of the shadow of well in Alexandria. So he took those data and calculated that the earth is spherical, and he calculated the circumference of the earth to a pretty good degree back then, which is astonishing if you ask me. Coming on to Hellenistic astronomy. In Hellenistic astronomy, there was an astronomer called Hipparchus. He was inspired by the Babylonians and created a star catalog and observed new stars, noted its luminosity, color, and position. So, as my friend Shantanu mentioned, the Babylonians created star catalog. So Hipparchus, who was greatly inspired by those Babylonians, created his own star catalog and added more parameters, which included luminosity, color, and position too. So which made the star catalog even better. In fact, even now we have of the stars we observe, we calculate the luminosity and color, and it is very significant. Coming on to the next astronomer, Seleucus, who correctly theorized that the tides were caused by the moon. Later on, he also studied tides in different parts of the world and concluded that tides vary in time and strength in different parts of the world. So, as we know, Newton developed the theory of gravitation, and his theory of gravitation suggested that every body pulls another body. So, with that, we can have a rough idea that moon actually has a control over the tides, but back then, the theory of gravitation was not yet discovered. So, Seleucus, Seleucus, he observed a lot of sea and concluded that when the moon is up in the when there is full moon, the tides are relatively higher. Using that, he theorized that the moon actually causes the tides. So, coming on, Hellenistic astronomers had a great impact on the world, and in fact, the kings of India, they influenced the kings of India to build observatories. The world was shown the beautiful world of astronomy. So, as we know, the observatory Jantar Mantar, if you know, Jantar Mantar is an astronomical observatory. So, it is one of the examples that how kings of India were influenced by the Hellenistic astronomy. So, coming on to the next civilization, which is the Egyptian civilization, with my friend Shantanu.
Thank you again, Soumit. So, Egyptian civilizations. Well, we all know Egyptian civil. Like the first picture that comes into mind when thinking of Egypt is the pyramids. But was there any astronomical significance behind the pyramids between the construction of? So, the astronomy in Egypt can be divided into two parts: ancient Egypt and Hellenistic Egypt. So, moving on to the ancient Egypt astronomy part. The annual flooding of River Nile coincided with the helical rising. The Egyptians observed it to be periodic and thus made a calendar of 365 days. And this all happened in the 11th dynasty of Egypt, which reigned in the 3rd millennial BC. So, at that time, developing a calendar which consisted of exactly 365 days, which is pretty close to the modern calendars, is astonishing. But how did the Egyptians did it? They observed the annual flooding of River Nile, and it also coincided with the helical rising of Sirius, a star. Which what do you mean by helical rising? First of all, helical rising is the rising of a star at dawn, but the sun is not visible. The star is, and it is much more luminous than it appears rather than it appears on rather normal occasions. And this happens annually, and its period is 365 days, which also coincided with the annual flooding of River Nile. So, thus, the Egyptians constructed a calendar of 365 days. Also, the Egyptian pyramids were aligned to true north by observing the pole star in the night and by using the sun's trajectory during the day. The direction of the true north was only off by 2 minutes and 30 seconds. So, how did the Egyptians, whether the pyramids have any astronomical significance? Yes, the pyramids are aligned. Every pyramid is aligned towards the true north. And how did the Egyptian astronomers achieve this feat? They observed the pole star, which was very still at the night, and they used the sun's trajectory during the day. And by using simple geometry, they calculated the position of true north, which, astonishingly enough, is pretty close to the modern measurement. The Egyptians also kept track of time based on their diagonal star table, which can be seen to the right, in which they kept track of time by observing different stars in different positions. So the Egyptians had a lot of constellations and had observed a lot of different stars. And in the day, it is pretty easy to keep track of time. If the sun is over your head, it is 12. If the sun is at the horizon, it is either dawn or it is late in the evening. But what about the night? So therefore, the Egyptians constructed the diagonal star table, which helped them keep the track of time. So moving on to the Hellenistic Egypt. Ibn Yunus, an astronomer of the Hellenistic period, predicted 40 planetary conjunctions and 30 lunar eclipses. using observations of the night sky and an astrolabe. So, what do you mean by astrolabe? It's a handheld sextant, so to speak. So, Ibn Yunus, of course, as I mentioned earlier, astronomy is not only about observing things, it is also noting down the data. So, this astronomer, Ibn Yunus, observed every planetary conjunction and has written down its observation in its own treaty. Also, a same astronomer of the same era, Ali ibn Ridwan, observed the supernova of 1006, which is believed to be the brightest stellar event in recorded history. He left the most detailed description of the event. So, till date, the supernova of 1006 is believed to be the brightest stellar event by many astronomers. And Ali ibn Ridwan, like obviously every astronomer observed this event in back in the day, but Ali ibn Ridwan was the only person who left the most detailed description of the event. So that concludes the topic for astronomy in Egypt. And moving on to the last civilization, China. Soumit, please take over.
Thank you, Shantanu, again. So, coming on to the astronomy in China. So, in China, there hasn't been a single kingdom which has ruled over the years. Rather, there has been many different dynasties. So, the two prominent dynasties when it comes to astronomy are Tang Dynasty and Song Dynasty. So, coming on to the astronomy in Tang Dynasty. So, in Tang Dynasty, there was a noted polymath called Zhu Chongzi, who, using his self-designed instruments, proposed that the year was 365.2428 days long, which is less than a minute different from the current measurement. Can you believe it? Like back then, during his era, which is 400 ADs, 400s AD, and back then he pointed out that the year was 364.2428, which is less than a minute different, which is astonishing if you ask me, considering the fact that he had limited resources. Coming on to the next astronomer, Ye Jing. He was the first known astronomer to try to plot the length of the degree of a meridian line, stating that it was 123.7 kilometers, not far off from the modern measurement of 111 kilometers. So, as we know, meridian is a longitudinal line. So, longitudes converge at the poles and at the farthest at the equator. So, Ying actually calculated the length of the distance between two longitudes, which were 1 degree apart. So, his measurements came out to 123.7 kilometers. But the modern accepted measurement is close to 111 kilometers, which is astonishing if you ask me, because he must have believed that the Earth was completely spherical. But now we know the shape of the Earth is not completely spherical; it is an oblate spheroid. So, coming on to the next dynasty, that is the Song dynasty. And the Chinese in this of the Song dynasty developed an accurate star map consisting of 1,434 stars and 28 constellations. So, as my friend Shantanu has demonstrated about the star catalog, so Chinese people kept a star map which used to plot out the maps at the night sky at the same time. Using those, they constructed a star map which had 1,434 stars and 28 constellations. So, in the Chinese culture, constellations matter a great deal because their months have like the month of the dog, the month of the cat, and they use the constellations which are prominent to be their months. So next there was an astronomer called Guo Shojing who invented a huge sundial and calculated the year to be 365.2425 days, which is just 26 seconds of the year's current measurement. Yes, exactly. That is an incredible amount of precision. 26 seconds with his limited resources. That is incredible. So thus the Chinese astronomy in China, the topic of astronomy in China comes to an end. So as we have learned that all the major civilizations played a major role in astronomy on what it is now. Because without those studies, we wouldn't have been in this place now. We have come a long way. We have like even have men on the moon. We have men who played golf on the moon. But without all these significant studies, it wouldn't have been possible. So I hope that people learn a great deal from this and continue the astronomy studies should be continued in the future. Thank you. So now we'll answer the questions.
Participants, please,
So
if you have any questions, please ask questions in the Q&A box itself. We'll try to answer.
audio disturbing, voice disturbing. Is there any questions?
We have an allotted time period for questions.
Okay,
But
so where a telescope in ancient history, Muskan asks. So telescopes was invented by Hans Lippershey in late 1500s or early 1600s. So most of the civilizations did not have any optical instrument. What is Hellenistic astronomy? Okay, Hellenistic astronomy, I think Shantanu should answer.
yes, Hellenistic astronomy. Hellenistic is a period in which the Arabs or the Islamic golden age was presented on the world. Like Hellenistic is an era in which the Islamic culture greatly advanced, and the Arabic took over a great deal of land. So that era is known as Hellenistic era, and the astronomy done in Hellenistic era is called Hellenistic astronomy. Hope that answers your question.
So Pradnya asked what is the sunrise equation. So using the Bhaskara II developed sunrise equation, which predicted at what time the sun will rise and what time the sun will set. So uh, he had three variables, that is the hour angle, declination of the sun, and the latitude at which the observer is observing the sun. Using those three variables and some simple geometry, Bhaskara II could calculate at what time the sun will rise and what time the sun will set. Hope that answers. And next is KS Reyes, whether USA not in astronomy. USA. The thing is,
USA.
Shantanu, would you like to?
So yes, of course. The USA, it is believed it was first discovered by the Vikings and all, but there were civilizations in USA. In Central America, yeah, there was a civilization called the Mayan civilization. But the sad part about Mayan civilization is that they had folks, they had verbal folks about their mythology and their astronomy, but not very much details and written records of astronomy did they perform. So Mayan astronomy have constructed many great monuments like the Chichen Itza. So Chichen Itza is constructed on the mapping of trajectory of Venus. So they were great mathematicians, yes, but were they great astronomers? Mm, it is debatable because there were no written records left by the Mayans people, not as much as we would like to share. So not much can be recovered from the Mayans, and hence Americans are left out in this presentation. Hope that answers your question.
So Pritham Ghosh asks what is difference between astronomy and astrophysics. Shantanu, will you like to answer?
If you can, yes, or yeah, I can too. Astronomy is observations and noting down the facts about different astronomical and celestial bodies. And astrophysics concerns more about the theoretical part and physical part and mathematical construct on astronomy. So the basic difference is that astrophysicists think on whether this theory will predict the planetary motion, whether this theory will uh, predict the conjunctions and all. But astronomy, it is simply observing a celestial body, noting down its information as much as you can, and there you go. You have astronomy. Amateur astronomers often are photographic astronomers. They take photographs from their amateur telescope. But professional astronomers, they sit at radio telescope and such, and they observe composition of planets and various different other elements which are present in the stellar space. But astrophysics, well, it is a philosophical subject, and astrophysics is a word based on the Greeks and all. So yeah, I hope that answers your question.
Next, Rohan Chini asked which supernova was observed in 1009. So the thing is, the supernova was observed in 1006 and it was observed in around late April or early May. So there are only written records of how it looked like. So it is believed to be the brightest supernova in existence. Some people say that it was visible in the daytime and it was as bright as there was two suns at the same time. People claimed that it looked as there were two suns at the same time. Hope that answered your question. It is not crab nebula. We are not sure if it is crab. There is some remnants. You can look it up, or we can get back to you by the end of the session if possible. So whatever Henry Vasantan asked, what about Kepler and Copernicus? They have significance in astronomy. The thing is, we have taken this civilization which were before Henry, which was before Kepler and Copernicus. So we have taken it before the Industrial Revolution took place. So Copernicus and Kepler came in much later. They were pretty significant. Yes, Copernicus had heliocentrism model. Kepler explained the motion of planets, how the planet's motion is eccentric and all that, and suggested equation Kepler laws too. Yeah, hope that answered the question. Just some. Is there any other civilization other than you told us who did astronomy? Ujjwal. So as my friend Shantanu mentioned, that Mayans had some significant studies in astronomy too, and there are some others which we may have missed out. You should. We'll get back to you by the end if possible.
Yes.
But I don't think we missed out a great deal.
These are the prominent civilizations, Ujjwal.
Yes.
The fact that many civilizations did astronomy, yes, it is true. The Assyrians did astronomy, and they are credited with the discovery, very first discovery of Saturn in the 8th century BC. And there were Mayans, and before Mayans, there were Olmecs in the Central America, which did astronomy too. And in China, there were many dynasties, but the more prominent dynasties we have discussed here. And if you really want more information, please get back to us after this seminar. Hope this answers. Thank you.
Okay, I think we have answered a lot of questions. There are a lot of questions left, but the thing is, we don't have much time. I really hope that we could have answered all the questions, but we have to get back to the session. So, if possible, we'll get back to you by the end of the session. But if not, then please don't be disheartened. So, we'd like to proceed with the event. I would now ask Anurag to take over.
Thank you, Viru.
Okay, that was very nicely illustrated and explained. Now, after getting some knowledge about history of astronomy, we can now talk about the key aspect of observational astronomy, that is light. So I ask Ashutosh to present the topic.
Okay, so a very cheerful good afternoon to all of you. I hope my screen is visible to all. Okay, so good afternoon all. Most of us must be familiar with the fact that our universe is continuously expanding. What if I told you we came to know about it by studying light? Light plays a very important role in astronomy. Let us discuss something about light. Now, what is light? Light is a form of energy. Light is photons and travels in the form of electromagnetic radiation. Now, what are photons? Photons are small packets of energy. What is EM radiation? It is a wave which consists of both electric fields as well as magnetic fields. Light with higher amount of energy will have higher amount of frequencies, and light with low energies will have low frequency. Now, what is frequency? The number of cycles completed by a wave in 1 second is called as frequency. Consider a simple example. If you are not familiar with the frequency, consider you are observing a pendulum. You start it observing from its position. Assume that its initial position, it starts from left. Then it's make its oscillation from left to right and then back from right to left. You observe this motion for a time span of 5 seconds. You observe that the pendulum returns to its initial position 5 times in 5 seconds. You will say that the frequency of pendulum is 1 hertz as said by the definition. Moving on to next. So, what nature does light follows? Basically, light follows dual nature, that is, it follows wave as well as particle nature. It follows both nature simultaneously. Just for example, in case of photoelectric effect, when an electromagnetic radiation hits any surface, we observe there is an emission of electron. Or in the case of phenomenon of interference, we are able to observe the wave nature of light. Now, moving on to how light is produced. So basically, we know light is made up of energy. Consider whenever an electron is given energy, it will always try to attain its stable state. And one way that electron can attain its stable state is to emit photon. When an electron jumps from a higher energy level to lower energy level, it will emit energy. Consider the diagram for better understanding. You can observe there is an atom, okay, with an A2 energy level and one with E1 energy level. The electron from E2 energy level is making a transition with some time span to the E1 energy level. So the difference between those two energy level will give us the energy of a photon. That's how light is produced. Okay, moving on. Let us talk something about electromagnetic spectrum. So based on the wavelengths and frequency ranges, light is divided into following categories that makes up the electromagnetic spectrum. That is, light is divided into radio waves, the microwaves, the infrared, the ultraviolet, the X-rays, and the gamma rays. Let us talk something about radio waves. Radio waves have a frequency range that is greater than 3 into 10 power 11 hertz. So basically radio waves is used in communication section, as you might be familiar with it. Moving on to the microwaves. The microwaves are also used in the communication section and also in case of microwave ovens. Radio astronomers also conduct observations in the microwave region. Moving on to the infrared. The infrared are used in television remotes as well as in night vision goggles. Most amount of energy which is emitted by any body at room temperature is in the form of infrared radiation. The infrared, the near infrared, which is just another segment of infrared radiation, allows people and animals to be observed. Moving on to the visible region. You all might be familiar with the visible region, the VIBGYOR, that is all the 7 colors of light. The visible region ranges from 400 nanometers to 700 nanometers. Moving on to the ultraviolet. So basically the ultraviolet light's basic application is that it is used as a disinfectant for viruses and bacteria and also used in water treatment plants, and then in some cases it is also used in drying of materials. Moving on to the X-rays. So X-rays has a major application in medical industry, that is medical field, that is it is used to identify the broken bones. Since X-rays take a longer time to travel through bones, that's why we are able to observe a clear image of those bones. Now, moving on to the gamma rays, and also one thing that the X-rays are also used in airport security to scan for baggage, to check for dangerous items. Moving on to the gamma rays. So gamma rays are basically used in the sterilization of food and also as a tracer in medical field. Also, since X-rays and gamma rays are most higher energy waves in the EM spectrum, they are also used to kill cancer cells. So that's all about the electromagnetic spectrum. Moving on, let us talk about the radiation emitted by our sun. Our sun emits all the radiation in the EM spectrum, which are radio waves, microwave waves, infrared waves, visible rays, ultraviolet rays, X-rays, and gamma rays. I will be sharing you some different images of sun in different spectrums. Observe carefully. So you can see the sun in the radio wave region. Just take a look. All right. Moving on to the next region. Take a look of the sun in the microwave region. All right. Let's move further. Take a look of the sun in the infrared region. That is, only infrared light is captured here. Okay. Moving on. Observe the sun in visible region. So here you can see the sun in the visible region. This is how our sun looks like in the ultraviolet region. Just take a look. This is how our sun looks like in the X-ray region. And that's the case where how our sun looks like in the gamma ray region. So how light is used in astronomy? Everything we know about universe comes from light. By studying the properties of light coming from any object, we can determine the elements present in it. Just for example, the Jupiter has methane in its atmosphere and Venus has carbon dioxide. All right, moving on to next slide. So the key to know the universe is electromagnetic radiation, that is light. Every object present in universe emits electromagnetic radiation. There are various studies which we can do in order to study light, such as spectroscopy and photometry. There is another very famous quote said by Nikola Tesla that in order to understand the universe, you must think in terms of energy, frequency, as well as vibration. And I can certainly say that light has its certain kinds of energy, frequency, as well as the vibrations. So, in the very starting part of session, I told you that we know that universe is continuously expanding, and we came to know about it by studying light. And that effect is Doppler effect. When we consider an example, consider you are standing. Okay, a sound source is approaching towards you. As the sound source approaches towards you, you will observe that the frequency of that sound source increases. That is, you will be able to hear high pitched sounds. And when that sound source moves away from you, you will observe that you are able to hear low frequency sound, that is, low pitched sounds. The same goes for light too. Whenever a light emitting source approaches towards you, its frequency increases, and we say that the light is blue shifted. And whenever any light emitting source moves further away from you, we say that the light is red shifted. So that's all. In the end, everything we know about the universe comes from light. Thank you. If you are having any questions, you can ask. Okay. So there was a question that stars can be converted into planets. No, that's not possible. Yeah. Yeah. So there is another question: is high frequency energy wave harmful for humans, and how? So, okay, yeah, high frequency energy waves are actually harmful to humans since they actually distort your cellular structures, basically. So, yeah, right. I have answered what is an electromagnetic radiation. Okay, so gamma, why is gamma ray photo of sun so different? Okay, let's take a look at it again. So basically, the gamma ray photo of sun is very different because most amount of gamma rays produced in sun is produced at its core, and when these gamma rays reaches to the surface of our sun, most amount of energy is absorbed since most amount of gamma rays is made at core. As it makes its way through the sun, most amount of gamma rays are absorbed. Okay? So that's all for now. Now I would like to pass on the mic to our session keeper, Master Anurag Maldhure. If there are any further doubts, you can definitely contact me. Thank you.
That was nice, Ashutosh. Uh, I would like to tell the participants that our team is trying to answer your questions in the Q&A section also. So you can have a look at it. And moving on, now we will be talking talking about the significance of space exploration and try to cover the basic ideas about it. So I call upon Master Abhirav to take the lead. And
So, good afternoon, one and all. First of all, I apologize for the delay, but now by considering that the screen is visible, I start with the presentation. So, first of all, I would like to introduce myself. My name is Abhirav Welekar, and today I will give you an overview of space exploration. So, let's start the presentation. So, when we are talking about space exploration, the first thing we should know that is what is exploration. So, exploration is the act of searching or finding for the purpose of discovery. The discovery of what? Discovery of new resources or new information. So, you all know that every living being on this planet explores. But what makes us humans different from other organisms is our range of exploration. Humans explore new ideas, they explore in art, they explore in new areas like space and almost everything around them. So they discover almost everything around them. So this habit of exploration itself makes us human. So with this, one more question comes in front of us, and that is, why do we explore? Why do humans explore? So these are the points you can see on your screen. So the first point is here is we don't know. See, as I told you earlier, humans are very curious. They want to know about everything. So when would one know about anything? The first stage is he should not know about it, right? So the first point is we don't know. Then I will explain it one by one. It's very simple. So first is we don't know. So when we don't know about a thing, then our longing to know that thing increases. As our longing increases, then seeking arises. And as seeking arises, the possibility of knowing about that thing increases. And once we know about the thing, then it may lead to discovery. So as humans have discovered many things till date, so all these discoveries has come from their exploration. So the next question we will deal is, what is space exploration or why space exploration? So why we are talking about space exploration? So it's obvious that anyone will explore all those things that are close to him or near to him, right? So space is closest to us after Earth. That's why space exploration. We should understand this with an example. So imagine that you are going out on a starry night with your father, and your father shows you the stars in the sky, right? So these twinkling stars induces a kind of curiosity amongst you to know about it, to know about the stars, to know about astronomy, right? So then you will explore in deep about that. So that's how exploration works, and this is how exploration is important. We understand this with the example that this exploration was there from our ancestors, as told by my co-presenters, Mr. Shantanu and Mr. Soumit. So we understand that this curiosity was there from our ancestors since thousands of years. So that curiosity itself has brought us to wherever we are today, right? So next, I will be telling you about the methods of space exploration. So the first method of space exploration is telescope. Then there is manned spacecraft. The next method is space station, and the last one is space probe. I will be explaining these methods in further slides. So let's move on to the first of space exploration, that is telescope. So as you all know that telescopes are used for observing the objects in the space, right? So telescopes are broadly classified into two types. The first is ground-based telescopes and the second is space-based telescopes. So these ground-based telescopes include the telescopes that work in the visible light, that detect the visible light, which includes the refracting telescope and the reflecting telescope. Then the ground-based telescopes also include the radio telescopes, as you can see in the image, this antenna. This is the image of radio telescope. So these radio telescopes detect the radio waves, right? Then the next type of telescope is space telescope. So we should understand first what was the need of developing such space telescopes, even after we can observe the celestial bodies through the earth. So as you know that the earth has a very thick atmosphere, right? It also contains the ozone layer. So certain electromagnetic waves like the UV rays, the infrared rays, the X-rays, they cannot penetrate to such a thick atmosphere. So that's why if we want to study the X-ray and other EM rays that cannot penetrate the Earth atmosphere, we have developed these space telescopes that continuously orbits the Earth, and as it's outside our atmosphere, it can easily detect those waves that cannot enter the Earth atmosphere, right? So this was all about the telescope. Now moving on to the next method, and it is manned spacecraft. So you all know that astronauts are launched into the space, right? Astronauts are also sent to space station for their research purpose. And what do they research? The astronauts research how space affects the human body and as well as on the growing plants, right? So you all also know that astronauts were sent to one more celestial body other than Earth, and that is the moon. They were sent to moon from 1969 to 1972, right? And after that, no man has kept his foot on any other celestial body other than the Earth, right? So we should understand this manned spacecraft. Manned spacecraft means any spacecraft that contains humans, right? It is manned spacecraft. So this was about the manned spacecraft. Now next method, and the third method is space station. So what is space station? A space station is a working laboratory for astronauts which permanently orbits the Earth. The astronauts that are launched into space, they are now launched to space stations. So they live on the space station for months and weeks and months, and for a long period of time, and they do their scientific investigations there. Then they also keep also maintain the space station, right? So here you can see the some name of some famous space stations. So this is Salyut 1 to Salyut 7 and Mir, which was launched by Russia. And the image you can see here is of Skylab space station that was launched by the USA. So this was all I wanted to tell about the space station. Now the last but not the least method of space exploration is space probe. So what is a space probe? A space probe is everyday name given to an unmanned spacecraft. In simpler terms, we can just say that any spacecraft that does not contain human is a space probe. So these space probes are of three types. The first one is flyby craft. So what do these flyby craft do? They just fly by their targets, or we can say that they travel past their target. For example, there is Voyager 1, the space probe Voyager 1. It fly by Jupiter, then Saturn, and it studied Saturn's moon, and then fly by uh, in front of the Saturn. And now it's in the interstellar space. So this was the flyby craft. Then the next type of space probe is orbiters. So what does these orbiters do? The orbiters just orbits continuously their target, right? So you can understand orbiters easily from the mission of Mangalyaan, or you can understand in a better way by the name Mars Orbiter Mission, that is MOM. So the orbiter is coming here. So these are the orbiters that continuously orbits their target. Now next type is the landers or rovers. So what does these landers do? The landers touch on the surface of their target, or we can say that they are landed on their targets. And these rovers, they travel on the surface of the target and they do all their study work, right? So this was all about the methods of space exploration. Now one more question comes into our mind, and the question is that how space exploration benefits humans, right? This is a very important question. So you can see the points on your screen. I will explain it one by one. The first point is GPS. So you all know about GPS system, right? So how does this GPS system work? We will understand this with an example. So you know that in earlier days when we have to go to a destination that is unknown to us or that is new to us, we would have to constantly ask the native people about the exact location of this destination that we want to go. And it was very time consuming job, right? You would ask n number of peoples about the location and they will tell you, and then you will reach there. So it was a time consuming job. So how does this GPS system work? So nowadays you just type the name of your destination in the map, and it gives you the road to how to reach to your destination. So this system has helped us a lot in saving our time and reaching our destinations very easily. So next is climate change. So how space exploration benefits in terms of climate change. So there are certain satellites that orbit the Earth. These satellites monitor the climatic change that occurs on the Earth. Like they monitor the melting of ice, then they monitor the rising of water in the oceans. Then these satellites also help to forecast the weather, and weather forecasting is very important. Like for example, if there is a tornado coming on the seashore, then if we already know about the tornado that or hurricane that is coming to the seashore, then we could evacuate all the towns that are near the seashore, right? So that's how space exploration helps in detecting the climate change. Then inspiring young people, this is very interesting, you know. uh, you all know, you should know that young people are interested by every other feat, every other great feat that is achieved by human, right? So how these young people inspire? They inspire to study mathematics, they inspire to study science and technology, they also are inspired to study about the space, right? So as these young people will get inspired and study science and technology, this would in turn definitely improve the technical competence of the nation, right? So as the more and more people will study about science and technology, the more they will gain knowledge about it, and this in turn develop the technical competence. Then the next point is innovation. So as there are benefits to human race through space exploration, there are also challenges for space exploration. What are these challenges? I will be telling in the next slide, but first understand this innovation. So these challenges, uh, sorry. So these challenges inspire us to innovate new and new technology, right? So the challenge for innovation is we will have to innovate new and new technologies or new and new devices that are much more capable, efficient and reliable, that can sustain in the space environment, right? So for developing such spacecrafts, we will require a continuous innovation in this field. Then the next point is economic prosperity. This point can be best understood from the example of ISRO. So what does ISRO do? ISRO launches satellites on a commercial basis, right? And satellites on a commercial basis, and the cost that ISRO offers is very reasonable. So many foreign countries ask ISRO to join their satellites, right? As you know that ISRO have launched 104 satellites at a time recently. So these countries they will invest in ISRO, and indirectly it will process economic conditions for the India, right? So this was all about the benefits of space exploration. Now, next, as I told you just now, that there are certain challenges to space exploration. You can see the challenges in your screen. So, the first and foremost challenge of space exploration is escaping the Earth's gravity. Right? Earth's gravity is a big factor or big challenge to space exploration, as we want to continuously launch vehicles outside the Earth's atmosphere. Right? So, you know that the bodies that are having less weight will escape the earth very easily. The bodies that have less weight can achieve high velocities very easily, right? So this is our next challenge, that achieving high velocities. So for achieving necessary high velocities, so first you all are knowing that escape velocity of earth is 11.2 kilometers, which is a very big, a very large velocity, right? So to achieve this velocity, we will have to we are needed to innovate new and new engines that uh, can achieve high velocities by consuming less amount of fuel, right? So here comes the innovation part. Then the next point is the vastness of the universe, right? So you know that the scale of the universe is very big. We should understand this with an example of Voyager 1. As I told you earlier about Voyager 1, so this Voyager 1 was launched in 1977, and after a long period of 35 years, it entered the interstellar space. It entered the interstellar space in the year 2012, right? So 35 years. Can you imagine? It's a very large period of time. Yes or no? Yes, it is a very significant period when we look with respect to human life. It's a significant period. So it's a challenge to the humans to achieve quick and easy space travel. So the next point is space radiation. What is space radiation? As you know that the Earth is surrounded by atmosphere and its magnetic field, right? So outside the Earth's magnetic field, the subatomic particles zip around at a speed near to the speed of light. So these subatomic particles can severely damage our spacecraft. So to manufacture spacecrafts that are more endurable, that are more sustainable to this space radiation is also a challenge. Then the next point is we should discuss is microgravity. So microgravity is a term given to a condition in which any object that is experiencing gravitational force, the object that is experiencing gravitational force, or we can say the amount of gravitational force that is acting on the object is very less. So this condition is known as microgravity condition. So as you know that astronauts are in the space station, they work in the space station, so there is microgravity condition over there. So this microgravity condition very badly affects our human body. It causes certain immune cells to die. Some blood cells also gets exploded. It the microgravity also damages our kidney. It may lead to kidney stone. Then our heartbeat also slows down in the microgravity. But not these much. But there are also some other effects on human body, like our bone density decreases and our muscle density also decreases. So that's one negative effect of microgravity on the human body. So the astronauts, as they're in space, they continuously work out or continuously exercise to tackle this problem, but it still affects their body in some or the other way. So tackling this microgravity problem is also a challenge to human. Then the next point is crashing is not an option. So we must understand this. When we are when we want to study any object by means of landers or rovers, then landing becomes very important. And you all are knowing the importance of soft landing from the example of Chandrayaan 2 that recently happened. So when we want to study the object using rovers, then crashing is definitely not an option, because it will hamper our study, and it will also hamper the it will also what we can say, it will also strike our economy, that we have money that we have invested in the what we can say, in this operation, in this exploration method. Then the last point is space debris. So what is this space debris? So as there is pollution on the earth, the pollution outside earth in space is called as space debris. So, so the space debris is a very big challenge to humans. So as there are as we are increasing our space exploration, we are increasing our launchings, right? So as we are increasing our launchings, the amount of space debris is also increasing day by day. Debris includes non-functional spacecraft, like the satellites that are in orbit, that are revolving around the earth in their orbit, and they are not functioning. So this is the space debris. Then there are also some staging parts, as the staging parts or fragmentation parts that we use while launching the rockets. So these fragmentation parts also contribute to the space debris. So on earth, you know that we are trying to minimize the pollution, or we are trying to reduce the pollution. So as we are trying to reduce pollution on earth, we also should try to reduce the pollution in the space, that is in the form of space debris, right? So that's also a big challenge to human beings. So in the end, I would only say that as we are humans, we love the challenges, and I hope that in the coming future, these challenges are successfully confronted by the humans. So thank you. This was all that I had to tell. I have completed my part, and now it's time for the questions. Audience, if you have questions, then you can ask in the chat box. So here is the question I'm seeing. What is microgravity by Kumari Jayashree? So Kumari, I have already answered it. What is microgravity? So I will again tell you. The microgravity is just a condition. It's a condition in which any object is experiencing very low amount of force or gravitational attraction. So that condition is termed as microgravity. I hope I have answered your question. Then what drives a nebula to form the stars? So this question so uh, Anush Anusha Sharma. So I don't know in much detail about it, but I know little bit about it, but I don't know it in detail. So I don't want to give you any incorrect explanation. So we can answer this at the end of the session if possible. Then explain ISRO's mission NETRA for space. So for space debris. So Aditya, I really apologize that I don't know about this NETRA mission, but I will study about it definitely. Is there any harm of debris to the Earth? See, who is this Shruti? The space debris, they continuously orbit the Earth, and there is a large amount of space debris outside the Earth's atmosphere. So there is a chance that these space debris can enter the Earth's atmosphere by losing their altitude. And if these space debris enter the Earth, then they will definitely crash onto the Earth's surface, right? So the maximum possibility is that they will crash into the ocean, but there is also a minimal possibility that it can hit the Earth's surface or the land on which we are living. So there is some, we can say, there is some sort of harm. So I think there are more questions, but as we have limited time, we can answer them in the after the session is over. So with this, I forward the mic to Mr. Anurag Maldhure, who is the uh, head, who is the event coordinator.
Okay, thank you, Abhirav. Unfortunately, the event coordinator, Mr. Anurag Maldhure, cannot be present here with us right now. So the show must go on, participants. The show must go on. So we have another one last session for you guys, which will be on space agencies by Shashwat Buradkar. So buckle up and let's get straight to the session. Mr. Shashwat, please.
Shashwat, your mic is not on.
No, it's not on.
Shashwat, please start from the beginning. I just unmuted you, so kindly start from the beginning.
Okay. Okay.
Okay, thank you.
Good afternoon, everyone. In this session, we'll be discussing about space agencies. This is a session in which we'll be discussing what are space agencies, why do we need them, and about some major space agencies. In particular, we'll be talking about agencies, their achievements, and their future mission. So without any delay, let's proceed. What are space agencies? The government agencies engaged in activities related to outer space and space exploration. There are 72 different space agencies in existence. 14 of them have launch capacity, whereas 6 of them have full launching capacity. The space agencies which have full launching capacities are the China National Space Administration, the European Space Agency, ISRO, JAXA, NASA, and Roscosmos. Now, what does that mean to have full launch capacity? This includes the ability to launch and recover multiple satellites and deploy cryogenic rocket engines and operate space probes. Now, after knowing what about space agencies, you must have a set of questions. First, what does a space agency do? Second, why do we need them? Third, why is government investing in a space agency? To answer this question, let's move on to the next slide. First, safety and security, that is, monitoring space and protecting our planetary environment. I can explain this with an example. Assume a asteroid is flying by the Earth. Who is going to tell us about that? It will be our space agencies. Second, the application that is using space to benefit and meet the future challenges on Earth. GPS is one of the great examples for this, enabling and support that's making space accessible and developing the technologies for the future. Now we know what a space agency do. Now, which are the major space agencies? Major space agencies. NASA, that is National Aeronautics and Space Administration, a space agency of America. Moving on to the next space agency that we are proud as Indians, the Indian Space Research Organization. Next is the Space Agency of Russia, Russian Federal Space Agency. Moving on to the next agency, the European Space Agency. Now, which is the Space Agency of Japan? That is Japan Space Exploration Agency, also known as JAXA. Last but not least, China National Space Administration, that is CNSA. Now we know about space agency. Now, before going in particular to any space agency, let's look at few terms. That is space age and space race. Space age is the time period from which a space race has started, and space race is just a competition between two rival nations in mid-20th century. That is America and USSR, means Russia. So let's go to our first space research center. The world's first space research center was established by USSR in 1955, meaning Soviet Union Space Program. The Soviet program was terminated in 1991 and re-established in 1992 as Roscosmos. This is how the Roscosmos was formed. Sergio Korolev is credited as being a founder of Soviet Union Space Program, and Yuri Koptev was agency's first director. Now we know about the establishment of Roscosmos. Now, what are the achievements in the name of Roscosmos? So, the Roscosmos achievement. Sputnik. Sputnik was the first artificial satellite the Soviet Union launched into the elliptical low Earth orbit on October 4, 1957, orbiting for 3 weeks before its battery died, then silently for 2 more months before falling back into the atmosphere. It was a 58 centimeter in diameter and it was having 4 external radio antennas. The main objective of Sputnik was radio broadcasting. It is said that after Sputnik, the space race has begun. Moving on to the next achievement of Roscosmos, the first man mission. The former Soviet Union maintained its lead by launching the first human into the orbit on April 12, 1961, with cosmonaut Yuri Gagarin making a history about his Vostok spacecraft. Further, the Soviets first include first women in space and first US spacewalk, followed in later years. And Soviet Union space program was the one who sent the first crew into the space in a vehicle named Voskhod. Moving on to the next achievement, first on Moon. With a space race in full swing, the former Soviet Union intentionally crashes its Luna 2 spacecraft, also known as Luna 2, on the Moon on September 14, 1959, to become the first man-made object to touch down on the lunar surface. Following the future Luna program spacecraft snapped the first images of the moon far side, and with 1971's Luna Cord landed the first ever wheeled rover on the lunar surface. One of the next achievement is surface of Venus. After several attempts, the first to pierce the thick veil of Venus, ever-present cloud cover to return the first ever image of planet's surface during Verena 9 and 10 mission of 1975. A series of Venera probes relayed the images and data from the surface of Venus through the mid-1980s. Even a decade later, the researchers are still remastering and studying those first views of the second planet from the Sun. Last but not the least, one of the most important achievement of Roscosmos, the International Space Station. As I told you about the founder of Roscosmos, it was Sergio Korolev. He was a man who put forward the idea of a space station, and after his death in 1966, the idea was carried out carried forward, and the first space station, Salute 1, was launched. After many years, the advancements were made, and in year 1998, the ISS, the International Space Station, was made in collaboration with 5 agencies, that is NASA, Roscosmos, JAXA, ESA, and CSA. CSA stands for Canadian Space Agency. Now what? Now we know about the achievements of Roscosmos. Now, what are the future missions? We don't have much details about future missions of Roscosmos, but they're planning to take civilians into the space in next decade. Now we know about Roscosmos. Let's talk about the rivals of mid-20th century, NASA. NASA stands for National Aeronautics and Space Administration. It is a space agency of America, which was established in October 1, 1958. Dwight D. Eisenberg is said to be the founder of NASA. Now we know the establishment. How was the NASA established? Now let's talk about the achievements of NASA. NASA have many achievements in its name. Here is a list of few achievements. Apollo 11. Apollo 11 was the first manned mission to land on the moon. The first step by moon on another planetary body were taken by Neil Armstrong and Buzz Aldrin on July 20, 1969. Possibly the best known achievement of NASA. More than 500 million people watched the broadcast and were thrilled to see how first man felt his mark on the surface of our satellite. The voice of the sculptor still sound today around this time. See, moving on to the next achievement, robot conquers Mars. Much is speculated and dreams of much is speculated and dream of conquest of Mars, the red planet, with a living on a day on its surface. But you think for a moment Mars have already been conquered by human beings indirectly. The planet is increasing pledged by robots or rovers, exploring the landscape and gathering information. Up till now, the NASA has sent 4 rovers onto the Martian surface. The name of rovers are Sojourner, Spirit, Opportunity, and Curiosity. Moving on to the next achievement, the Juno mission. In August of 2011, the Juno mission took off the destiny to Jupiter. It was a study from a gravitational field of a planet to atmosphere plagued by a storm that gave it. It will also search for the clue about how the planet formed, including whether it has a rocky core, amount of water present within a deep atmosphere, mass distribution, and its deep film, which can reach a speed of 618 km per hour. Moving on to the next achievement, the Voyager units. The space probe Voyager 1 and Voyager 2 are objects created by human beings that has reached farthest in space. At the moment, both are on their way to Earth cloud, the last region where objects are still affected by sun's gravity, the last frontier of solar system. 2 years ago, the Voyager 2 probe reached the interstellar space, the territory that had already been reached the sister Voyager 1 a year before. The two were launched into the space the same year in 1977, with just a few days of difference, but by the conditions of each journey, Voyager 1 went ahead, reaching the interstellar space in 2012 to 18,000 million kilometers from the Earth. Moving on to the next achievement, the eye of NASA, the Hubble telescope, the first space telescope. Astronomers needed a sharper image to study the universe and decided to change their strategy. The atmosphere of Earth, full of cloud, water, gas vapors, distorts the light coming from the space, preventing the taking of clear photographs, even if the lens is of best quality. The engineers decided to take photographic equipment out of the Earth atmosphere, creating a space telescope. Of all those that were made in Hubble in honor of astronomer Edwin Hubble has been the most important of US Space Agency. This was all about the achievements of NASA. Now, what are the future missions of NASA? First, the NASA ISRO Synthetic Aperture Radar, also known as NISAR. In this mission, they are going to build a satellite to use 12 frequency. Next mission is Euclid, which is a mission to investigate the cosmic mysteries of dark matter and dark energy. Next mission is Europa Lander. In this mission, they are going to send a lander to the Europa, one of the satellites of Jupiter. Interplanetary nanospace pathfinder in the environment. This is a mission to find the revolutionary capability of deep space. For those who don't know what is deep space, a space beyond 2 million kilometers from Earth's surface is deep space. Next is space agency that we are proud of as Indians, ISRO, or Indian Space Research Organization. The ISRO was formed in 1969 with a vision to develop and harness space technology in national development while pursuing the planetary exploration and space science research. The ISRO replaced its predecessor, INSCOSPAR, Indian National Committee for Space Research, established in 1962. Vikram Sarabhai is said to be the father of Indian space program. Vikram Sarabhai was an Indian physicist and astronomer who initiated the space research and helped to develop the nuclear power in India. He was honored with Padma Bhushan in 1966 and Padma Vibhushan in 1972. Now, we know about the establishment of ISRO. Now, let's talk about achievements of ISRO. Satellite launch vehicle. It is a launching vehicle of ISRO. Our first satellite, Aryabhatta, was launched on satellite launch vehicle in 1975. The satellite launch vehicle was developed under the able guidance of APJ Abdul Kalam. So, moving on to the next achievement. Okay, these are the series of launching vehicles that ISRO uses and ISRO made. SLV, ASLV, PSLV, JSLV Mark 1, CSLV Mark 3. These are the characteristics of this rocket. Please take a look at it. Okay, moving on to the next achievement, Chandrayaan. In 2008, India's space mission to the moon was made by India with the launch of Chandrayaan. Most importantly, it was used to study the topography of the Earth. It was intended to survey the lunar surface for a 2-year period to produce a complete map of chemical composition at the surface and three-dimensional topography. The polar regions are of special interest as they might contain water ice. Among it, many achievements were the discovery of widespread present water molecules in lunar surface. This is how the mission was executed. What were the objectives of Chandrayaan-1? First, expanding scientific knowledge about the moon. Second, upgrading the India's technological capability in space. Third, preparing a three-dimensional atlas of both near and far sides of the moon, conducting a chemical and mineralogical mapping of entire lunar surface. The satellite launch vehicle used for Chandrayaan-1 was PSLV-C11. It had a lifting capacity of 316 tons and height of 44.4 meters. It was launched from Satish Dhawan Space Center. This is all about Chandrayaan. Let's move on to our next achievement, Mars Orbiter Mission, also known as Mission Mangalyaan. The ISRO successfully launched the Mars Orbiter Mission, also known as MOM, using PSLV-XL in 2013, and it was one of the biggest achievements of ISRO. In 2014, India was able to reach Mars successfully at its very first attempt. Notably, only the three other space organizations have been able to achieve this. They are NASA, European Space Program, and Soviet Union Space Program. This tells you how the mission was executed, which path did the satellite to go to the Mars, and which was the launch vehicle. The launch vehicle used for Mars orbital mission was PSLV-XL. It was a very cheap mission. It only cost for 450 crores. The satellite launch vehicle used, that is PSLV, have lift-off mass of 1,350 kg and dry mass of 500 kg. These are details about Mars orbital mission. So moving on to the next achievement, that is launching 104 satellites together. ISRO launched 104 satellites using a single rocket from a spaceport Sriharikota in Andhra Pradesh. Notably, it achieved this record with the help of 6 other nations using PSLV-C-37 in 2017. The Polar Satellite Launch Vehicle, that's PSLV, blasted off from India's Satish Dhawan Space Center at 10:58 p.m. with 3 satellites from India and 101 smaller nano satellites from 5 other countries, that is, the US, the Netherlands, Israel, Kazakhstan, and Switzerland. The number crushes the previous record of 37 satellites sent into orbit across a single Russian Temper rocket in June 2014. Next achievement, NAVIC, navigation with Indian constellation. NAVIC is India's own navigation system, similar to the US GPS. It worked based on the Indian Regional Navigation Satellite System, that is IRNSS. There are currently 8 IRNSS satellites in geosynchronous and geostationary orbit. NAVIC is fully operational and is doing a great job. Currently, 8 satellites are already in orbit. 7 satellites are being used for navigation purpose, 1 satellite only for messaging purpose. Some are based on NAVIC are already functional and being immensely used. 2013 was India's first navigation satellite. Now, I want to tell you about the fact that we might be using phone radar map, right? It uses a NAVIC navigation system. So now we know about the achievements of ISRO. Now, what are the future missions? Future missions: Chandrayaan 3, again a mission to the moon. Gaganyaan, the first Indian human space flight program. Aditya L1. In this mission, we are going to send a probe to the sun to study the solar corona. These are, as I told you, in future of NASA. They are going to build a satellite to use dual frequency. Then Mangalyaan 2, again a mission to Mars. Shukrayaan, our first mission to the Venus. We as humans have achieved very much in the field of space exploration, and there is much more to come. Thank you. If you have any questions, please ask in the Q&A section.
Thank you, Shashwat, for this amazing presentation. Now we are heading over to the end of the ASTROMINAR webinar. So before we observe actual live observations, we have a small PPT on today's important astronomical event, which is an eclipse. So I call upon Master Soumit to enlighten us with
Me taking all the credit.
Correct.
How do you feel?
Soumit, you can start.
Yes.
Thank you.
Okay. So as you know, today is the annular solar eclipse. So the annular solar eclipse, these are two. The left side is a image about how the timeline image, while the right is the event at its peak. Solar eclipse at its peak. You can see a diamond ring. It's called a diamond ring. So eclipse. So what exactly is an eclipse? So eclipse is conjunction of sun, Earth, and the moon. So in a solar eclipse, what happens is the moon comes in between the sun and the Earth, casting a shadow. So as you can see in the image on the right side, as you can see, the moon is coming in between the Earth and the sun, causing a shadow, and thus we look it up as an eclipse. The lunar eclipse, which is on the left side, is when the Earth comes in between the sun and the moon. So for a few duration, the moon is completely hidden, even though the day should be of a full moon. The moon is completely hidden for some time. After that, it appears back, and it's mostly reddish in color because red is the red is the most prominent radiation or most prominent wavelength. Thus, it's red in color due to various other factors too. So coming on, today is the annular solar eclipse, June 21st. So these are how this is how a solar eclipse looks to the with a telescope with solar filter. So as you can see, the chromosphere, which is the atmosphere of the sun, is visible. There are prominences and coronas are visible, and there's something called Bailey's head, which is visible, which will come to it in a second. So this is these are the places where the perfect solar eclipse can be seen. Perfect solar eclipse. I've shown the photo in the first slide. So in India, these are the regions where you can see the perfect solar eclipse. It's in Uttarakhand, there's in some in Punjab, Haryana, and a little bit of Rajasthan. And observe the perfect solar eclipse. So information via solar eclipse. So what is the significance of solar eclipse to astronomy as a whole? So in 1868, the first evidence of helium was discovered due to a solar eclipse. So as my friend Ashutosh had mentioned about spectrography. So using the spectrography during the solar eclipse, we found out that sun consists of a lot of helium, which was studied by the French astronomer Jules Janssen during the total solar eclipse in Guntur, India in 1868, August 18th. So, moving on, the next information via solar eclipse is by the Eddington experiment, which was an observation test of general relativity organized by the British astronomers Frank Watson Dyson and Arthur Stanley Eddington in 1990. The observations were of the total solar eclipse of 29 May 1919 and were carried out by two expeditions, one in the West African of Principe and other in Brazilian town of Sobral. The aim of the expedition was to measure the gravitational deflection of starlight passing near the Earth, passing near the Sun. The value of the deflection has been predicted by Einstein in 1911 paper and was the test proposed for his 1915 theory of general relativity following the return of the expedition. The results were presented by Eddington to the Royal Society of London, and after some deliberations were accepted, widespread news coverage of the result led to worldwide fame for Einstein and his theory. So, according to general relativity, light actually bends when it's around heavy objects. So, this is what they calculated. Next, it helps you to study the corona through coronagraph images. As the corona and the solar material spreads outwards from the sun, they can manifest themselves as disturbances in near Earth space, known as space weather. Space weather models that are developed are likely to characterize the structure of the corona in order to improve forecasts of the path and possible impacts of the event. So, I've shown the solar eclipse image and peak. So over here, so as you can see, there are a lot of corona. Like as my friend Ashutosh explained what corona is. So according to that, we can see you can study a lot of corona due to the event of solar eclipse. So there are applications which tell you when the next solar eclipse is coming on, and these are some websites where you can learn more about solar eclipse, the next eclipse, and how they are calculated on. So there are some certain myths in town about the solar eclipse. So we'll try to address that. So an eclipse is a natural phenomena, but in ancient cultures they were attributed to supernatural causes as and regarded as bad omens. But nowadays, with advancement in science and all, we know that that's not true. So in some parts of India, people fast during the solar eclipse due to the belief that cooked food during an eclipse is poisonous and impure. And in many cultures, young children and pregnant women are asked to stay indoors during a solar eclipse. So we know that that's not true, as we have had many advancement in science. So the food you can cook food perfectly fine. There is no risk of it being poisonous or impure. So next, there are messages circulating over social media stating that COVID-19 pandemic is affected by solar eclipses, which there was a solar eclipse on 26th December. Uh, Last year, and the COVID-19 pandemic started at December 31st. So people are saying that the solar eclipse was the cause of this pandemic, but most probably it is not, because there is no correlation between pandemic or virus and solar eclipse. So the ancient Greeks believed that solar eclipse was a sign of an angry god, and that it was the beginning of disaster and destruction. So Greeks, even though they are pretty smart, but they are not that smart in talking about solar eclipse, as you can see. So they believe that it is a punishment of gods and beginning of disaster, which does not make any sense. It is if there was a disaster or destruction, it must have been pure coincidence. So next, the Pomo, an indigenous group of people who live in northwestern United States, tell a story of a bear who started to fight with the sun and took a bite of it out of it. In fact, the Pomo name for a solar eclipse is sun got hit by a bear. So how a solar eclipse is caused has different stories in different cultures. So an indigenous group in northwestern United States has a legend of Pomo who looks looks like it's eaten away. So not all supernaturally planted during solar eclipse are brighter and more colorful than the flowers planted in any other time of the year. So Italy in Italy naked eye, that is without any aid. Do not look through X-ray film and similar material. Do not look through a telescope, binocular, or glass without a proper filter. So how to see it? So here we have your answers. By using a pair of certified eclipse glasses. So there are some big observatories which manufacture such eclipse glasses, are certified and can be used to observe such solar events. So next, by using a filter with binoculars or telescope. So there are some filters which can be attached to binoculars or telescope to watch such events. Next is the pinhole method. That is a diagrammatic representation of the pinhole method. So you take a cardboard and make a pinhole, and you use refraction basically and get a image. So that's how it works. So reflected image projection on screen using a mirror. So that is another method. And next is online observation session, which we are going to have now in a few minutes. And we had one earlier too. So thank you for listening. Now I'll pass my mic back to Shantanu.
Thank you, Soumit. And I hope every participant learned the pros, cons, do's, and don'ts of the eclipses and how to watch them and how not to do what you're not supposed to do. So, we will be straight on jumping on to the observation session of this AstroMinar webinar. And to start off the events, we will be seeing a time lapse which is compressed from 2 hours to 2 minutes. This is today's annual solar eclipse time lapse. And I present to you the time lapse, and it will be played by it will be played right now. Please proceed.
Hello, everyone. So, as most of you joined at exactly 12:30, you might have seen the exact live view of the solar eclipse, which was going on at 12:30. We know that the solar eclipse started at around 10:30, and the peak was at around 11, and it was about to end at around the time when we started the session. So when the people who joined the session at exactly 12:30, they saw the live footage which was broadcasted by the Indian Astronomical Observatory, which belongs to the Indian Institution of Astrophysics. So it was a live view from Leh Ladakh. Now what we did, we just recorded the video, the whole duration of the eclipse, and it has been the speed has been fast forward to 60 times. So the 2 hour footage is now available in a 2 minute footage. So kindly enjoy the view, a time lapse view of the solar eclipse which has happened this morning. So I request Rohit to please play the video. As you all saw the video, it was a time lapse. So first we saw almost completely visible sun, which was then covered by the moon shadow partially, and it was approaching towards the ring of fire. But unfortunately, in India, we the ring of fire was not exactly visible from any region. This was the most this was the most area that was covered, which was visible from India. So this was the view from Leh Ladakh. So the northern part of India had the most clear view. So I request Rochit to please play back to that part wherein we had the peak. So as you're seeing, this is the peak that we observed from India. In few parts of the world, people were able to see the ring of fire, but unfortunately from India we weren't able to see the ring of fire. This was the peak from India. So we see a crescent-like shape of the sun, so which is covered by the shadow of the moon. So yeah, this was the mostly visible from India. So I would like to hand over the mic to Shantanu back again. So kindly continue with the observation sessions and for the further videos. Thank you. Over to you, Shantanu.
Thank you, Haardik sir. So, observations. We have galore of observations. We are gonna actually observe Saturn and Jupiter from telescopes situated way over to the other end of the world, which is in Spain, Canary Islands. But technical complications and weather conditions are not our best friends today. Due to some weather conditions and technical issues, the telescopes, the Canary Island telescopes are not observing any celestial bodies. So to compensate that, we actually had another observation session in the morning itself where we actually observed Saturn and Jupiter. So this is the recorded video of this morning from 10 a.m. to 11 a.m. We actually observed Jupiter as well as Saturn through the SLU telescopes. SLU, you will get to know what is SLU and about interesting facts about Saturn and Jupiter. Can we please play the video?
Am I audible? Hello?
Yes, Anurag, you are audible. You may continue.
Okay, so that was all about the observation session. Now, I would request our faculty in charge, Ranna ma'am, to address the meeting and share her feedback. Ma'am, are you there? Please unmute your mic.
Hello.
Yes, ma'am, you are audible.
Hello. Good afternoon, everybody. At the first, to begin with, I must congratulate the Astronomy Club of our institution to hold this event. All the speakers who spoke today, they were very well prepared. They have taken huge labor, and the topic is astronomy, astrophysics are the topics which are so wide. Hello, which are so wide that becomes very difficult to cover the all aspects associated with it, but most of the details have been revealed. At this platform, I must I want to thank the participants also. About 135 participants were there, and all of them have remained attentive, present throughout the session as I was observing. So, a big thank to them also. See, astronomy, astrophysics is the subject in which India is doing really good, and therefore we must have this opportunity. This is the field where engineers have lot many things to do, and I want all of you being at home, refresh your knowledge on astronomy, astrophysics, get associated with astronomy club, and upgrade your knowledge about it. As astronomy or the space science is the future today, we know that the life on life, or rather existence of the other planets, is being explored significantly. The reason behind is that as per it is said by the Amazon CEO, that the other planets are not being explored for the human habitation, but we can explore the other planets for carrying out those activities which are hazardous but necessary for the human sustenance. We can carry out those activities outside the earth, and we can keep our earth as a safe environment for the human habitat. So that is how these explorations are going on, and I want that, because India is doing good, if we join Indian astronomy development or the space programs, the future will be really very bright. Thank you very much, all of you, once again. I request Principal Sir, as I could see he is there, so I request him to say a few words.
No. So I was really enjoying the Astronomy session right from 12:30. There were wonderful presentations. We could get the real feel of the solar eclipse, and they have managed to get it from Ladakh with the help of Indian Institute of Astronomy. There were wonderful presentations by the various student coordinators about the different modes, like how the exploration and how the solar, rather the astronomy can be understood by the various missions, and their lot of what I call it, the solar exploration program agencies, and so many other issues. In fact, for it was a good thing for me to learn so many things out of this webinar, mainly dealing with astronomy. And I really appreciate the efforts taken by the students, then the faculty, and also all the supporters. I'm sure the Astronomy Club in the future will add some more dimensions and will be more popular among the students, as well as will reach outside our campus to the various colleges, schools, and we are doing. I wish you all the very best of luck. Thank you.
Thank you, ma'am and sir, for explaining your valuable views and being with us. So here we come towards the end of the today's webinar, that is Astrominar. Before we end the meeting, I would like to thank faculty that includes our principal sir, faculty in charge, and Dr. P.R. Deshmukh sir joining us in the Astrominar. We are thankful for your support and cooperation to make this event possible. I would also thank participants for being attentive audience in this webinar, and thanks for participating in the online event. We hope that we provided you the best knowledge we could offer in the limited time. We are committed to bring even more interesting events in the future. But now the last but not the least, I thank all my core team members who have worked for public relations, content creation, and technical support. We are thankful for senior members of the club for their valuable guidance. Thank you, everyone. And now I would request everyone to fill out the feedback form, whose link will be shared in the WhatsApp group and the chat box, so you can get the certificates. And with this, we conclude our today's event, that is Astromina. Thank you.
Thank you.
Participants are requested to fill the feedback form. It is being shared in the chat box as well as in the Q&A box. So you'll find the link over there and also in the WhatsApp group. So kindly fill the feedback form, and after filling the feedback form, you will receive your e-certificate shortly in your emails. So kindly fill the feedback form to receive your certificates, and also